Hello, we're going to be learning about indices today. This is also known as exponents or powers, and as you can see is this little number up there, and this 2 or this one piece down here is called the base. Okay, so those are key things moving forward. Okay, just like in any new form of algebra, we're going to have lots of laws or rules that govern kind of how these things operate. So here's the first few. A to the m times a to the n is going to be the same thing as a to the m plus n. Now these things have the same base, a, and that's the only time that we're allowed to do this. And notice that we're multiplying here, but then we're going to be adding here. So that kind of pattern is going to hold all the way through these indice rules, okay? Example of numbers is going to be 2 to the 5 times 2 to the 3 is going to give 2 to the 8. So the bases are multiplying together, but we're going to add the exponents or add the indices here to 8. Next one is a to the m divided by a to the n, and this one is used quite a bit and is a source of a lot of errors for people, but is very important. So you're going to have m minus n up here, so it's the same thing. Multiplication is to addition as division is to subtraction, okay? So you can see 2 to the 5 divided by 2 to the 3 is going to be 2 to the 5 minus 3, and therefore it's going to end up with 2 to the 2, right? This next one still fits the same pattern, right? So we have a to the m raised to the n. So this is an indice, right? And so indices are to multiplication. So it's always like one order of operations down, right? So this is going to be a to the m times n. So 2 to the 5 raised to the power 3 gives you 2 to the power 15. So this is where we multiply here. Now this next law is the one that a lot of people mess up on, make mistakes with, but it's crucial to understanding your higher level algebra. And so we get a to the 1 over m is equal to a to the root m. Okay, and so this one we might need a bit more explaining. Where we'd get 27 to the third, to the power third, is equal to the cube root of 27, right? So you want to be able to interchange back and forth between these two things. Another example would be 81 to the half is going to just be the square root of 81. So this one doesn't have the little number up in the third sign here, but that 2 is used so often that it's just sort of ignored. So we assume that if you just see a square root, it's going to be 1 over 2. So that's going to be the square root of 81. The next law is another really important one. So a to the minus m is going to be the same thing as 1 over a to the m. Okay, so this one is used a lot. It needs to be memorized. A real easy example is 3 to the minus 1 is equal to a third. And a more complicated example would be all of 5x to the minus 3. Now that means everything in that bracket is going to be underneath the fraction line here. And so that's going to be 5x all to the 3. And so that means the 5 and the x. This is using another one of our rules, a to the m all to the power n, right? So both of these are going to be power 3, which gives you 125x to the 3. Okay, notice the difference between this one and this one here, that this one does not have the brackets, and so it's only this x that's getting raised to the power 3. This 5 is not, so this is another common error people will make. Not on purpose, of course, it's just like kind of a brain slip here, so that 5 stays on the top and it's only the x that goes down below. Just make sure that you are reading things carefully, because it's easy to slip from this and think it's this, or to read this and think it should be this one here, okay? Brings us to our last law here, and so we're going to have a to the m over n is equal to a to the m root n, or the nth root of a to the power m. Now it can be written both ways, and that's a bit confusing, but it just kind of depends which one you need at that time. So both of them are tools in the tool belt here to be able to use to solve lots of different questions. But this one causes people a lot of trouble, so make sure that this power up here on the top of the fraction is always the power of m inside the third symbol here, and it's this one, this n, is always the piece that's attached to the third sign in both cases, right? Now, it is a little confusing for people if you haven't seen this before, that you can do this and this, and it comes out to be the same thing. But essentially, it's the same thing as an example would be 3 to the power of 2/3 is going to be equal to the cube root of 3 squared, right? Now, this rule gets used a lot when we get to calculus and stuff because we like this form for calculus, but we do not like this form for calculus, okay? So it does get used a lot for interchanging one form of algebra into another. So you're going to have to memorize all of these things if we can. And how do you memorize? You just do it over and over and over again until it becomes routine, sort of like training your brain muscles. You got to put all of this into the brain, this into the brain. All of those rules need to go into the brain box and to be used over and over and over again. So practice helps with this. If you want to write the rules down, it does help if you're trying to memorize things. Usually in math, that's the way I recommend stuff. So you just write it down over and over again so that you don't have to try to memorize everything all at the end, okay? So we'll move on to some examples. So one of them is just simplify, is a basic thing that we're going to do. So we're just going to multiply in here. So this is going to be, both of these pieces are going to be multiplied. So we're going to get a to the 4, because it's going to be 2 times 2, and then b to the 3 times 2, which is 6, right? So pretty simple one there. Here's another fairly easy one once you get used to the rules. So we're going to have 2 to the power minus 4, right? So that's the same thing as 1 over 2 to the 4. And you can use a calculator for this, but hopefully this one's not too bad in your head. So that's going to be 1 over 16. Okay, here's a few rules combined on this next one here. So we get 5 to the 13 times 5 to the 5, all of it divided by 5 to the 7, right? So on the top, we're going to have 5 to the 13. Now this 5 here has a hidden 1 there, right? So whenever you see just a number by itself, there's a hidden 1 right up there. So that means it's going to be a 13 plus a 1 on the top. And so we still have this on the bottom. So that's going to turn into 5 to the 14 over 5 to the 7, which then we get to, now you kind of want to skip this step and just do it in your head, but that's going to turn into 5 to the 14 minus 7, which should then equal 5 to the 7 altogether, which is a bit harder to do in your head, so we can try a calculator with that one. Equals 78,125. So not quite that easy to do in your head, but some people might be able to do it. I'm not one of them. I need a calculator. So we're going to make things a little bit more difficult. So this question looks fairly ugly here, as Yoda is telling me up there. However, we do have to try difficult questions if we're going to get really good at math. So we've got to challenge ourselves, right? You'll thank me for later, I'm sure. So this one, we're going to just do it step by step, piece by piece. So we want to make it as small as possible first. We just look at the first bit here, handle that, look at the second bit, handle that, and then handle this and try to put it all together. That's the general strategy when going through big, large algebra pieces like this. Okay, so let's get for the first one. So 3 to the half raised to the power 8 is going to give us 3. Now you're just going to go 8 over 2. Now you don't need to write this one if you wanted to go straight to 4, but we'll write it anyways just to make sure. Now the next one is going to be the same thing. We're just going to multiply the minus 3 and the minus 2. So that's going to give us 6, right? And we can handle the bottom one as well. So minus 1 times minus 2 is just going to give me 2. All right, so that's the first step. Then we sort it out again, handle this first one. So we're going to get 3 to the 4 times 3 to the 6 over 3 to the power 2. Simplify the top, group the top of the, so that's going to be 3 to the 10 over 3 to the 2, and then that's going to be 3 to the 10 minus 2, which is going to give us 3 to the 8, right? So we had, let's go through that here. So the multiplication, 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 simplify this guy, then we're going to add those pieces to 10, then we go 10 minus 2 because this is on the bottom. That's just one way to handle it. You could have handled this 2 earlier, because it does go into both technically, but that's kind of a more complicated process. So I like to try to say to make it as small as possible in every step if you can do that. So we're kind of squishing the top together and then into one piece, and then sort that out there. It seems to be the easiest. Now 3 to the 8 is again another one of those things we need on the calculator. You get 6,561. Now quite often in A levels and things like that at the higher level, that you might want to keep things as 3 to the 8 rather than this larger number here. It depends on what you're needing it for. Also, this one here, they're probably not going to ask you on the current A-level model in the UK here, because this can all be done on calculator, right? So there's probably not going to be this much unless they specifically say to show all workings for this, in which case you would have to show all the indices rules. But more likely they're going to combine it with something a bit harder than this. I should specify that when I say they, I mean like the exam boards and things and the examiners and how they're going to set questions. Okay, so let's look at this, some rather monstrous one. And again, same thing. We're just going to sort it out piece by piece. Do not panic, right? Hopefully that doesn't freak you out. I just love that one. Don't panic, Kenny's on the case. All right, so how do we handle this thing here? Well, there's a few things that you can do right away, and you can probably see that the numbers can be handled right away. So we could do that straight off. So 18 divided by 2 is going to be 9. It's just going to be on the top there. Now, with the y's, x, y's, and z's in here, that we have to handle the same thing. We're going to use BIDMAS, right? So we're going to do the brackets first, and so you sort that out first. So that's going to be y to the minus half, z to the 2 times minus half is just going to be minus 1, right? When in doubt, always check on the calculators if you need to. On the bottom here, we're going to have 2 times a half is just going to be 1, right? And then we're going to have y to the half here. Now, on this step, you can see that we've got y's on the top and the bottom, so we should be able to combine those two, right? The 9's going to stay there all the way through, so that's going to be 9. Now, we're going to have a minus a half up here. Let's just highlight this piece here. So you're going to get y to the minus a half minus, now y is on the bottom here, and there's the hidden 1. So that's y to the 1 here. So that's going to be y to the minus 1.5, which you can write as a mixed fraction, but it's usually preferable to write it as a top-heavy fraction like that. So that's going to be y to the minus 3 over 2. Now, you can keep that up here if you wanted, like that. Or you could, and then write x as minus 1 and z as minus 1 as well. That's good for calculus, that form, because it's all kind of just indice, all in the indice here rather than having a fraction line. Or you could write this as 9 over all of these things. So that's going to be y to the 3 over 2 x. And then probably people out there are looking at, oh, why are you putting the x after the y? So, you know, just preference. It's fine. I'll sort it out. I know how people get 3 over 2, and then you get z. Sorry, that's a z down here. Okay. Now you might want to go back over that one just in case, because it's a bit messy. You might want to write it out yourself as well, because especially with indices and a lot of algebra work, you don't necessarily want to follow other people's. You want to kind of do it your own way, make sure it makes logical sense to you, that each step makes sense, and you map it out for yourself, okay? Okay, make sure you're doing lots of practice with these because you want this to become routine. While you're going through these, and especially when you encounter new algebraic rules, at first it might be a good idea to say the process in your head, so kind of sounding it out or reading it as you're doing it, and it helps you double check on a certain level that you're not making any errors, okay? So try to do that until it becomes absolutely routine. Okay, if you found this helpful, make sure to like the video and subscribe to the channel. It should be all linked together for you. And make sure you check out SURDS. I think is going to be the next one on here in most syllabuses. So SURDS is going to be in there. Proofs is also in the A-level one, so you might want to check that out too. Algebra rules and things like that. Okay, hope you learned something, and see you next time.